Welcome to a method of undetermined coefficients example. So for this example, we are to find the general solution to y double prime plus 5y prime plus 6y equals e to the negative 2x times the polynomial 5x squared minus 1. So the first thing, if we're looking for the general solution, we might as well just find the general solution to the homogeneous equation first. So the first thing we're going to do is find the general solution to the homogeneous equation. So we are looking at y double prime plus 5y prime plus 6y equals 0. This has characteristic equation of r squared plus 5r plus 6 is equal to 0. And the characteristic equation factors is r plus 2 times r plus 3 equals 0. So we get r equals negative 2 or negative 3. That means that we can take our y1 to be e to the negative 2x, our y2 to be e to the negative 3x, and we have general solution or homogeneous general solution y is equal to c1 e to the negative 2x plus c2 e to the negative 3x. Once we've done this, then we need to determine our base guess for the method of undetermined coefficients. So determine the base guess for yp. So in this case, again, we were looking at y double prime plus 5y prime plus 6y is equal to e to the negative 2x times 5x squared minus 1. E to the negative 2x was a root, or negative 2 was a root of our characteristic equation. E to the negative 2x was a solution, right? So this is a solution to the homogeneous. So that's a multiplied by x. (5x squared minus 1). We're looking at degree 2. So our base guess we are looking at a yp equaling, we need to multiply by x because e to the negative 2x was a solution, negative 2 was a single root of our characteristic equation, times e to the negative 2x times a degree 2 polynomial, a2 x squared plus a1 x plus a0. So again, we need degree 2 to match the degree 2 of our right-hand side. We have the e to the negative 2x to match the e to the negative 2x, multiplying our original polynomial. And then we had to multiply by x, since e to the negative 2x was a solution to the homogeneous equation. From here, we plug yp into the equation. And solve for the coefficients. So we have yp is equal to x e to the negative 2x times all that. I'm going to multiply in the x. We have yp is equal to e to the negative 2x times a2x cubed plus a1x squared plus a naught x. That's just multiplying in our x. The first derivative, we would have a negative 2 e to the negative 2x times that whole polynomial, a2x cubed plus a1x squared plus a naught x. And then to that, we would add e to the negative 2x times 3a2x squared plus 2a1x plus a naught. For our second derivative, we would have a positive 4 e to the negative 2x times a2x cubed plus a1x squared plus a0x. Then we would have actually 2 copies of negative 2 times e to the negative 2x times 3a2x squared. So we have plus 2 times negative 2 e to the negative 2x times 3a2x squared plus 2, that's not a 2, plus 2a1x plus a naught. So the first thing I wrote here, that first line of yp double prime came from the product rule, differentiating the negative 2 e to the negative 2x and keeping the a2x cubed. That second term I wrote, one piece of it comes from the product rule of the first line, being a negative 2 e to the negative 2x times the derivative of that a2x cubed plus blah, blah, blah. And the second repeated part of that is the second line of yp prime doing derivative of e to the negative 2x and then multiplying by 3a2x squared, blah, blah, blah. We have one final line, which is the last half of the product rule of the second line. We keep e to the negative 2x, multiply by the derivative of 3a2x squared, blah, blah, blah. So this becomes plus e to the negative 2x times 6a2x plus 2 times a1. If we plug all of this into the equation, so plugging into y double prime plus 5y prime plus 6y is equal to e to the negative 2x times, we had 5x squared minus 1, or 5x squared plus 0x minus 1. Y double prime, we have a 4e to the negative 2x times a2x cubed plus a1x squared plus a naught x plus 2 times negative 2 becomes minus 4e to the negative 2x times 3a2x squared plus 2a1x plus a naught plus an e to the negative 2x times 6a2x plus 2 times a1. That here was just y double prime. Then we have plus 5 times negative 2 e to the negative 2x times a2x cubed plus a1x squared plus a naught x plus e to the negative 2x times 3a2x squared plus 2a1x plus a naught. That was the plus 5 times y prime. And then we have a plus 6 times y. So e to the negative 2x times a2x cubed plus a1x squared plus a naught x. And all of this added together should equal e to the negative 2x times 5x squared plus 0x minus 1. So this is a rather nasty left-hand side. I'm going to go ahead and lump my terms. So we'll lump together the x cubed terms first. So our x cubed terms, we have a 4e to the negative 2x times a2. I'm actually going to divide everything by e to the negative 2. We can just clear our e to the negative 2's and lump terms, or we'll just factor out our e to the negative 2 out front. So our e to the negative 2x is going to factor out front of everything. What we have multiplying our x cubed, we have a 4a2. Then we have our next a cubed term, we have a 5 times negative 2 times a2 becomes a negative 10 times a2. And then our last a cubed, x cubed term, we have a 6 times a2. So plus 6 times a2. All of this was multiplying x cubed. Then we should have an x squared term. For x squared, we will have a little more involved. So we have a plus 4a1 multiplying x squared from that first line. Then we have a minus 12a2. So we have a 4a1 minus 12a2 times x squared came from the second line. Let me update my screen quickly. So far, we've done the first and second line. Our third line has no x squared term. So now we'll drop to that fourth line. We have a plus 5 times a negative 2 times an a1. So we have a minus 10 a1 x squared. So we now have a minus 10 times a1. The fifth line, we have just a 3a2 times x squared. So we have a plus 3 times a2. And then in our sixth line, we have a plus, oh, sorry, we also have that's times 5. So that should be a plus 15 a2 from our fifth line. So we have that plus 5 out front multiplying our 3a2. So we should have a plus 15 times a2. Then from our sixth line, we have a plus 6 times a1 for the x squared term. These get brutal very quickly. Then for our x term, from the first line, we have a 4 times a naught times x. So we have a 4 a naught. From the second line, we have a minus 4 times 2 times a1, so a minus 8 times a1. From the third line, we have 6 times a2 in front of our x. So we have plus 6 times a2. From our fourth line, we have a plus 5 times negative 2 becomes negative 10 times a naught times x. So we have minus 10 times a naught. From the fifth line, we have a plus 5 times 2 times a1 times x. So that becomes a plus 10 times a1. And from the sixth line, we have a plus 6 times a naught times x. So we have a plus 6 a naught. All of this is multiplying x. And then finally, we have our constant term. So our first row has no constant term. Our second row, we have a -4 times a naught. Our third row, we have a 2a1. So we have a -4 a naught plus a 2 times a1. Our fourth row, we have no constant term. The fifth row, we do have a constant term, which is a 5 times a naught. So then we have a +5 times a naught. And then all of this together should equal our right-hand side of e to the -2x times 5x squared plus 0x minus 1. So our highest order term does cancel out. This was again why we had to multiply by that additional x. 4a2 minus 10a2 plus 6a2 cancels out all to 0. So what we get for matching coefficients is that 5x squared should match our 4a1 minus 12a2 minus 10a1 plus 15a2 plus 6a1 x squared. So 4a1 minus 10a1 come and then plus 6a1. The a1s just cancel each other out. 4a1 minus 10a1 plus 6a1. We're just left with a -12a2 plus a 15a2. So we get 3a2 is equal, or 3a2 times x squared should equal our 5 times x squared, or 3a2 should equal 5. For our next one, let's do a different color. We have 4a0 minus 10a0 plus 6a0. Our a0s cancel out here. We have a -8a1 plus a 10a1, and then we have a plus 6a2. So all we would be left with here, we would have a 6a2. And then plus 2a1. That's all multiplying x. This should match our 0x. And so we have 6a2 plus 2 times a1 should equal 0. And then for our constant term, we have a -4a0 and a plus 5a0, and then we have a plus 2 times a1. I'm just going to verify I'm not missing any terms here. So we had a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 terms. From our 3 lines here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 terms. So I do have all my terms. All right. So again, this last one becomes -4a0 plus 5a0 is just a0, and we have 2a1 plus 1a0 should equal our constant of -1. So the first part was the x squared term, left and right hand side. The second part was our x term. And this last component was our constant term. So So this problem now boils down to solving the system that we have. So now what we need to do is solve the system. Our first equation was 3 times A2 is equal to 5. Second equation was 6A2 plus 2A1 equals 0. I'm going to space these out in a moment. So the first equation, we had 3 times A2 was equal to 5. Second equation, we have 6 times A2 plus 2 times A1 equals 0. And our last equation, we have 2 times A1 plus A0 is equal to -1. So I'm just going to do a series of substitutions. This problem is perfectly set up for that. So 3 times A2 equals 5 means that A2 is equal to 5/3. So there's our A2. 6 times A2 plus 2 times A1 equaling 0. We have 6 times 5/3 plus 2 times A1 is equal to 0. That means that 2 times A1 is equal to -10, or A1 is equal to -5. So there's our next value. And then the last equation, 2A1 plus A0 is equal to -1. This becomes 2 times -5 plus A0 equals -1. And we get that A0 should be equal to 9. So our particular solution, YP, becomes X times e to the, what were we working in? -2x times our A2 was 5/3 x squared minus 5x plus 9. And our general solution we should just have y is equal to C1y1 plus C2y2 plus our particular solution. So we get that y is equal to C1 times e to the -2x plus C2 times e to the -3x plus x e to the -2x times 5/3 x squared minus 5x plus 9. As you can see, this problem took a fair amount of time to work our way through. Method of undetermined coefficients, it gets rather annoying pretty quickly once our polynomials have degree higher than, say, 1. So as soon as we have that quadratic term, we've got 3 coefficients involved. Our derivatives get rather complicated, and our equations can get annoying. But this is how we can go about applying the method of undetermined coefficients.